Hi, in this video we're looking at section 2.3, which is writing equations of lines. So we have already talked about one form, which is the slope y-intercept form, where y is by itself on one side of the equation, and then you have a number times x plus b, which is just another number. The number that's multiplied by x is your slope, and the b, or the number that's added or subtracted at the end, is your y-intercept. So let's look at a couple other forms of a line. We also have the point-slope form, which is particularly useful when you have the slope and a point that's not the y-intercept, and you still want to find the equation of the line. So your point that you'd be working with would be the point x1, y1, and you would just plug it straight into this formula where we have y minus y1, so whatever that number is from that point, equals m, so the slope, times x minus x1, where x1 is the number from that ordered pair. And then finally, standard form, which we've also kind of mentioned this as well when we were talking about what linear equations in two variables look like. So standard form is where you have a number times x plus a number times y equals a number. So this number that's multiplied by x is always positive, and then a, b, and c, so those are just numbers, those are whole numbers, so they're not fractions. Now here, I would actually say they're integers because although a has to be positive, b and c don't. And so integers are basically whole numbers plus numbers that are negative, right? That still are not fractions. So we have another couple sorts of lines that we've talked about already. Specifically, x equals a number and y equals a number. When you have x equals a number, that's the equation of a vertical line. And when you have y equals a number, that's the equation of a horizontal line, because all the y values are the same with a horizontal line, and all of the x values are the same with a vertical line. Knowing what we know, write the equation of a line with a slope of 3/4 and that goes through the point 0, 5, and then graph it. So this point here, it's very important to notice that the x value is 0. And because the x value is 0, that actually makes this a y-intercept, which means I'm given the slope and the y-intercept. So hopefully that rings a bell in here and tells you that you should be using the slope y-intercept form when you're writing the equation of the line, because all you have to do, if you're specifically given the y-intercept, it doesn't work if it's a different point, but if it's the y-intercept, you can just plug the numbers in. So we would have y equals 3/4 x plus 5, because b is your y-intercept and 3/4 is your slope. So we have our equation. So now all I have to do is graph this thing. Since the y-intercept is 5, that means that we know a point on this line. So we go ahead and plot the y-intercept, so 1, 2, 3, 4, 5. And then we use the slope to go ahead and plot another point. The slope is 3/4, so that means I go up 3 and to the right 4, so positive direction for both. So 1, 2, 3, and 1, 2, 3, 4. And specifically, it's the positive direction for both because my slope is positive. So it's either positive direction for both or negative direction for both, because a negative divided by a negative would also make this fraction positive. So I could also go down 3, so 1, 2, 3, and to the left 4, so 1, 2, 3, 4, because that's the negative direction for both. And then it's a good thing that these look like they're all in a row, because then I just need to put a straight line through all these points. Just like this. So what happens if my problem has the slope but a point that's not the y-intercept? Find the equation of a line that has a slope of 4 and goes through the point 5, 6. Now that point is obviously not a y-intercept, so I can't just throw it into the slope y-intercept form. However, I can use the point-slope formula. So this guy. So x1 and y1 are the numbers that are in this ordered pair, and our slope is 4. So plugging in what we know, we would have y minus 6 equals 4 times x minus 5. And so if you were asked to rewrite that in slope y-intercept form, you would have to distribute the 4 And then you'd have to add the 6 to both sides. So you'd end up with y equals 4x minus 14. So then, what if you're given a problem where you're supposed to find the equation of the line, but you're not even given the slope? All you're given are 2 points that the line goes through. Well, thankfully, if we're given 2 points, we know how to find the slope. So first thing I'm going to do is actually find the slope. So remember, that's y2 minus y1 over x2 minus x1. So that's going to be 5 minus 2, so the second y value minus the first y value, divided by negative 3 minus 1. So 5 minus 2 is 3, and negative 3 minus 1 is a negative 4. So my slope is actually negative 3/4. So now I have the slope and a couple points to choose from. So now that I have a slope and some points, I can use the point-slope formula. So we're going to have y minus, I'm going to use the point 1, 2, just because I think it looks a little bit easier. You could use the point negative 3, 5, and you'd get the same equation. So I'm going to have y minus 2, since that's the y value from the point I'm choosing, equals negative 3/4 times x minus 1. And so here, if you were asked to rewrite this in slope y-intercept form, you'd have to distribute the negative 3/4, and you'd have negative 3/4 x plus 3/4, because a negative times a negative, right? So negative 3/4 x, and then negative 3/4 times a negative 1 is a positive 3/4. And then I'd have to add 2 to both sides. But in order to add the 3/4 and the 2, I'd want to rewrite the 2 with a denominator of 4. So I'd be looking at y equals negative 3/4 x plus 3/4. And then actually plus, if I multiply the top and the bottom of this by 4, I've got plus 8/4. So 3/4 plus 8/4 means I'd end up with y equals negative 3/4 x, because that didn't change. And then plus 11/4. So there, now it's in slope y-intercept form. Now I know the slope is negative 3/4 and the y-intercept is actually 11/4. So these are kind of weird examples, but let's say that you're asked to find the equation of a line that has an undefined slope and goes through the point 1, 7. So remember, an undefined slope means that the slope has 0 on the bottom, and that only happens when the x values are the same. So that means that we're actually looking at a vertical line here, which means that the equation is going to look like x equals something. So we know that our equation is x equals something, so what's the x value of a point it goes through? So it goes through the point 1, 7, and the x value there is 1. So the equation is just going to be x equals 1. The second kind of weird example I have here is find the equation of a line that is horizontal and goes through the point 1, 7. So if it's horizontal, that means the y values are always the same. So you're going to have y equals a number. And in this case, the y value of the point it goes through is 7. So I'd have y equals 7. You could also be asked to write the equation of a line that has to do with lines that are perpendicular or parallel to it. So in this problem, I have write the equation of a line that goes through the point negative 4, 9, and A is parallel to y equals 5x plus 2, and B is perpendicular to y equals 5x plus 2. So same line, just one time we're looking for a line that's parallel to it, and the other time we're looking for a line that is perpendicular to it. So again, what do we know about parallel and perpendicular lines? So for part A, the lines are parallel. Remember that if two lines are parallel, their slopes are the same. So then we know the line that we are looking for has a slope of 5, because the slope of this line is 5, and they're parallel, so they have the same slope. So now we know that the slope of the line we are looking for has a slope of 5, and we know that it goes through the point negative 4, 9. So we have a point and a slope, which hopefully tells you that we should be using the point-slope formula. So we'll go ahead and just plug numbers into it and try to simplify as much as we can. So we would have y minus 9 equals 5 times x minus a negative 4. Remember, minus a negative is the same as plus a positive. Oh, shoot. Okay, so I'm going to try to simplify this as much as I can. We end up with y minus 9 equals 5 times x plus 4. And then if I distribute that 5, I have 5x plus 20 on the right-hand side. And then if I add 9 to both sides, we end up with y equals 5x plus 29. And that's the line that we are looking for. And then in the second, part of this problem, it's very similar, except finding the slope is the different part, right? Because what do we know about the slopes of perpendicular lines? We know that the slopes of perpendicular lines are opposite reciprocals. So the slope of this line is 5. So what is the reciprocal of 5? That would be 1/5. And this one was positive, which means our slope is going to be negative. So negative 1/5. So now we know the slope of the line that we're looking for, and we know that it goes through the point negative 4, 9. So again, we can use the point slope formula, and we would have y minus 9 equals, this time, negative 1/5 times x minus negative 4. So we'd have y minus 9 equals negative 1/5 times x plus 4. This time I'm distributing a negative 1/5. So I have negative 1/5 x minus 4/5. Because remember, 4 is the same as 4 over 1, and when I multiply fractions, I multiply straight across, which just means you multiply the numerators together and you multiply the denominators together. Now 9 is the same as 9 over 1, and if I multiply the top and the bottom of that by 5, I have y minus 45 over 5, and the reason I'm writing it that way is because the fraction over here that I'm going to be adding it to has a denominator of 5. So when I add them together, I'm going to end up with y equals negative 1/5 x plus 41/5. Now, you might want to actually work that one out yourself, right? I didn't write this down. So you put plus 45/5 plus 45/5. Make sure that I'm actually right there. Okay, one more thing. So we're wrapping this up with a word problem. And the word problem says, a cell phone plan costs $100 for the telephone plus $85 per month for service. Write an equation that gives the cost, y, in dollars for X months of cell phone service using this plan. So, couple things to think about. Remember that the slope is the rate of change. So what is changing here? How much you're paying depends on how many months you have that service, right? So your rate of change is the amount that you're paying per month. So I know that my slope here is my rate of change, and I'm paying $85 per every month that I'm paying for this service. So it's going up by $85 every month. That's the rate of change. So the total cost that I'm paying is y, and that's going to be equal to 85 times the number of months that I actually have that phone service, plus I have to pay $100 to even have the plan. So you pay $100 up front, and then every month after that, you're paying an extra $85. So I hope that makes sense how that's set up. Sometimes you might have a word problem where you're given two ordered pairs. So maybe the year is what X stands for and the cost is what Y stands for. And if you're given two ordered pairs, you can find the slope, and then you can use the point slope formula to find an equation. But with that, I think I'll call it good here, and I will see you later. Bye.